So here we have a situation in which IQ scores have a mean of 100 and a standard deviation of 15 and a normal distribution. We know that this is true about IQ scores in the general population. And it's asking if a person is randomly selected from the general population, what's the probability of getting a person with an IQ below 122? So we know that this is a z-score probability question because we have a normal distribution. We have we have a population with a mean that's known, a standard deviation that's also known, and a normal distribution, and a single person is being randomly selected. Um, that's how we know it's this type of situation. So let's see here. I'm going to change the number so it's not 122, so I don't just give out the answer. So let me change this to 117, and I'll show you how to solve for 117. And then on your assignment, just follow my steps, but solve it for 122, like the assignment says. So first we have to do our z-score formula. So it's going to be the number that we're turning into a z-score, which is 117, subtracted by the mean, 100, divided by the standard deviation, which is also provided, it's 15. The mean and standard deviation are provided. So what we're going to do now is subtract on top and divide by 15. If you feel like you haven't seen this formula before, look back to your notes from a couple of weeks ago, back when we were still in class, and also um, look at the video I posted on Introduction to Z-scores, and you'll see that this is the Z-score formula. It's the value you're turning into a Z-score minus the mean divided by a standard deviation. So 17 divided by 15 equals 1.13. And in this type of a problem, you have to leave 2 digits after the decimal point in order, because you have to do that in order to use the z-table. So we're going to make our answer 1.13. The third digit is a 3, so we round down. This number stays at 3, right? So it's 1.13. And I'll put a plus in front just so we know that it's a positive z-score. So now we have to we're going to go to the z-table next, but we have to figure out what our row and column are in the table. We have to find out what row and column we're going to be going to. So to figure out which row and column we go to in the table, we have to break apart this z-score into 2 pieces. So this first part, well, the first 2 digits tell us the row. So the row is 1.1, and the final digit always tells you the column, so it's column 3. So the row is always 2 digits with a point right in between, and the column is always the final digit. So let's go what we're going to be doing is going to row 1.1 and column 3. And our z-score will be where the row and column, our answer will be where the row and column meet up. So here's the z-table you'll need to be using. I'll share it with you through a message. So here we have 2 tables side by side. We have a table for negative z-scores. Notice how these are all negative numbers at the left end. And we have a table for positive z-scores. So we have a positive z-score of 1.13. So we go to the positive table on the right side. We go to row 1.1. We go to column 3. And we get 0.8708. So 0.8708 is the probability of randomly selecting a person below an IQ of 117. It's the answer to our question. So what the z-table does is it gives you the probability of randomly selecting an individual below a certain number. That's why the area to the left is shaded. So in our problem, this point right here is 117, and the shaded area is the entire population below 117, which is what so basically, what we just solved for is the probability of getting a person from this blue area, which is everything below 117. So like I said, it is 0.8708. Sorry, that's the other part of the assignment. And now this part B is asking, what percentage of the general population has an IQ below 122? So I'm going to change it to 117 to match the problem I'm solving. To get this answer, we just take the probability from part A and multiply it by 100. If you multiply a probability by 100, you turn it into a percentage. There we go. So 87.08% of the general population has an IQ below 117. And in case you're curious, this actually is the truth. In the real general population, there really is 87.08% below 117. So we're actually solving a real life problem here. So now, what we're going to be doing now is turning this into a diagram just to show what we've solved for. And there's a few things I want you to include. So draw the normal distribution, put the mean at the center. So the mean IQ of the population in our problem is 100. And put the z-score of 0 just as a reference point right here, just to say that we know that the mean has a z-score of 0. That's always true. And now let's mark off the number we turned into a z-score, which is 117. In your problem, it'll be 122. And let's put the z-score that goes along with an IQ of 117 down here. We when we solved for the z-score of 117, we got 1.13. So that's what's going to go here. So we have the mean and its z-score, the IQ we solved for, and its z-score. Now let's just do a couple more things here. Let's shade the part of the population that we're focusing on. So we're focusing on the population members below 117. So let's shade that part of the population. Sorry. I just have to make sure I close this. There we go. Now let's mark off let's label the probability of randomly selecting a person from this area. So we know that the probability of randomly selecting a person from this area is 0.8708. And we also know that 87.08% of the population is in this area. And this is what this is basically saying right here. And once you label the probability, that's it for the diagram. But make sure that you put everything in the correct place. So put, let's see, make sure you put the z-scores down here and the probability up here at the top. Make sure you don't get them switched around, because I've seen some students sometimes put the z-score up here instead of, and then put the probability down here. So make sure you just put everything into the correct places. And yeah, that's pretty much it. And let's see, I gave you a couple other types of z-score problems. So I'll just show you one or two more examples quickly. Let's now imagine that I asked you what's the probability of randomly selecting a person above 117, and everything else about the problem is the same. Well, if I ask you for above instead of below, you'll just do one extra step at the end of the problem. So the z-table gives you the probability below 117. So if you want the probability above 117, you do 1 minus the below probability, and you get the above probability. So basically you do 1 minus the number from the table, and you get the answer you're looking for. So it's 0.1292. Then if you want the percentage of the general population above 117, you would just take this answer and multiply by 100, and you would get 12.92%. And then the diagram that you make is the same, except you shade going toward the right instead of to the left, because now in this problem we solved for the probability of getting a person from this red area, which is everything above 117. So the probability of getting a person from this area is 0.1292. The probability of getting a person from the white area is what we solved for in the last problem. It was 0.8708. And if you're wondering why we subtract 1 by the below probability, it's because the entire curve is equal to 1. Well, the entire curve is 100% of the population, right? And 100% is 1 when you write it as a decimal. So what we're doing basically here is 100% minus 87.08%, and we get the other percent. So here we have roughly 87%, here we have roughly 13%, and it all adds up to 100%. That's how it works. So this is what you would do for an above problem. Calculate the z-score, look up the number from the table, and do 1 minus the number from the table. And make sure you get a positive answer, because if it's negative, then you switched these two around. It has to be a positive answer. Then do times 100 and get your percentage, and then make this diagram shading to the right. And now I'll quickly show you the last type of problem on the assignment. This is the third type of problem that I gave you on today's in-class assignment. It's a question in which I ask you for the probability of randomly selecting a person between two IQ scores. In this problem, I changed this part right here to between 117 and 121. So now it's a between problem. So what we need to do for a between question is solve for both z-scores. So what I did here was I turned 117 into a z-score, and I turned 121 into a z-score using the same formula that we've been using, and I got the two z-scores. Then what I did was I looked up each z-score in the table using the row and column. This z-score came out to 1.4, and I had to add a 0 at the end. so that I had a column digit. So it's column 0. And I got these two numbers from the table, 0.9192 and 0.8708. Once I get to that point, I just subtract the bigger number from the smaller one, and I get the answer at the end. So you don't subtract the two z-scores. You don't subtract 1.4 by 113. You look them both up, and then you take the two numbers from the table and you subtract those, like I did here. And let me quickly explain what's happening here. So 0.9192 is a probability below 1.13 to the left. 0.8708 is a probability below 1.4, because remember that the table always gives you the probability to the left. And when you subtract the probability to the left of 121, well, I'm sorry. Think of it this way. Here we have 117. And here we have 121. And I'll put 117 right here, just so we'll need this for later. So what the table gave us when we looked up, when we solved the first part right here, was the probability to the left of 117. So here we have 117 with its z-score of 1.13. And the probability of getting a person below 117 came out to 0.8708 from the table. And the probability to the left of 121 came out to 0.9192. And if we want the probability just between 117 and 121 in this little area, what we have to do is subtract subtract out the area to the left of 117. So we have to get rid of all of this area below 117. And all of this area to the left of 117 is equal to 0.8708. So if we subtract 0.9192 by 0.8708, we're basically subtracting out this shaded piece from the bigger piece, which is everything to the left of 121, and we're left with the leftover part, which is this white area. So you subtract the part from the whole, and you get what's left over, which is this. And this right here comes out to 0.0484. So that's, if you're wondering why we do it this way, this is why we do it this way. I just explained to you why it's done this way. And here, so once you get the probability for part A, you turn it into a percentage. So just like before, multiply by 100. This would be 4.82%. And make a diagram showing the probability of getting a person from the shaded area. And shade the area that we're focusing on, which is, in this case, between two numbers, 117 and 121. And so in your diagram, include the curve, the mean with its z-score of 0, the two IQ scores um, that we used in the problem, 117 and 121, their two z-scores, the shaded area, shade this area, and put the probability up here, and that's everything that you need to include to get the full credit. Um, and yeah, so now we've covered all three types of z-score situations, below, above, and between.